The last concept that we're going to cover in chapter 4 is adding and subtracting with mixed numbers. Now, this concept isn't too fundamental for algebra, so we're going to cover it, but you'll notice that there's only a couple homework problems because it just really isn't essential to learning algebra. But it is obviously good in problem solving and just giving you more practice with fractions because, again, we are going to be using fractions a lot. So adding and subtracting with mixed numbers is pretty much the same as adding and subtracting regular fractions. However, remember when we're multiplying and dividing fractions, we always have to put that into an improper fraction. We don't use mixed numbers when we're multiplying or dividing. However, when we're adding and subtracting, we can use mixed numbers. If you want to turn it into a mixed or an improper fraction, you can, but you can leave it as a mixed number and work through it just fine. So our first couple we're going to look at are going to have common denominators, and we'll see how that works. And then our last two aren't going to have common denominators, and we'll see how that works. So you'll see that it's basically the same thing as adding and subtracting regular fractions and whole numbers. And you'll see we're just kind of combining those two concepts together. So in our first one, we're going to be adding 5 1/3 and 6 1/3. So if you wanted to, you could write this as 5 1/3 plus 6 1/3. And if you write it vertically like this, you can kind of see how it lines up. You're going to be adding the fractions separately and then adding the whole numbers separately. So 5 plus 6 is going to equal 11. And 1/3 plus 1/3. And it might be easier to see that horizontally instead of vertically, but if the denominators are the same, we know that it's going to stay the same in the answer. 1 plus 1 equals 2. So we have our whole numbers and we have our fractions. We just add the whole numbers and then we add the fractions. All right? So pretty simple. And in this case, we can't reduce the fraction at all. So now let's look at subtraction. 2 7/8 minus 1 3/8. So again, 2 minus 1 is going to be 1. And then the 8s are the same. The denominator is the same. So it's going to stay the same in the answer. And then 7 minus 3 equals 4. And 4 8s can be reduced. So this can be reduced to 1 1/2. So we can divide the 4 and the 8 both by 4. 4 divided by 4 is going to give us this 1. 8 divided by 4 is going to give us this 2. So 1 1/2 would be the answer that we would be looking for. Again, always putting in lowest terms. Now, what happens if we don't have a common bottom number? Well, the same thing that we learned in previous section, we have to work through those. Okay, we got to get a common in order to solve it, in order to add or subtract. So those rules still apply. But in this case, we don't have to worry about the whole numbers. The whole numbers are going to stay the same. We're just making equivalent fractions. So the whole numbers are being left alone. So we're going to have a 1 and a 4, and we have an 8 and a 2. 2 actually goes into 8 evenly. So 8 can be our common denominator. It's our least common multiple because 8 goes into 8 and 2 goes into 8. So we can leave this 5/8 by itself and then just multiply the top and the bottom of this fraction by 4. So 2 times 4 is going to give us an 8 on the bottom. 1 times 4 is going to give us a 4 on the top. And now we can just add across. So if we add 1 plus 4 equals 5, and then 5 plus 4 equals 9. All right, so again, when we're adding and subtracting, once we have a common bottom, it stays the same in the answer. But if we look at this, 9/8 is more than 1. It represents more than a whole number. So when we're writing a mixed number, this is not how we write it. Because if this on the top, if the numerator is equal to or greater than the denominator, then that's representing a whole number in itself. So 8 goes into 9 one whole time, correct? So that one whole time is going to be added to the 5, and 5 plus 1 is going to give us 6. And then what's left over? If 8 goes into 9 one time, we have 1 left over because 8 to 9 is just 1. And we'd have 6 and 1/8. So 5 and 9/8 is the same thing as 6 and 1/8. But this is the proper way to write that mixed number. So again, when we're dealing with mixed numbers, improper fractions are not good. You can leave a number, turn this whole thing into an improper fraction if you wanted to. But if you're working with mixed numbers, you don't want to have an improper fraction within a mixed number. All right, so our last one is going to be subtraction. And yet again, we do not have a common, so we need to go ahead and make it common. And also, on this one, the same is true. Our whole numbers are going to stay the same. So we're going to have a 9 and then -2. And then we just need to figure out what our fractions are going to be. So a 10 and a 3, the least common multiple for a 10 and a 3 is 30. So there's not another number that 3 and 10 go into before that. So we're going to have a 30 on our bottoms. So we multiplied this by 3 to get 30. So we got to multiply the 7 by 3 to get the new numerator. So 7 times 3 is 21. Same thing over here, 3 times 10 equals the 30. So we're going to do 1 times 10, which equals 10. So now we can go ahead and just subtract the whole numbers. 9 minus 2 equals 7. And 21 minus 10 equals 11. And since 11 is a prime number and it doesn't go in to the larger number, then we know we can't reduce that or put it in lowest terms, or this already is in lowest terms, but we can't reduce it any further. So our answer is just going to be 7 and 11/30. So those are just a couple problems. Like I said, I don't have a lot assigned on this chapter. So if you don't fully understand it, please don't worry about it, because it's really not that fundamental or essential to learning, to building up to algebra and what we're going to be doing in math too. But it is good just to get familiar with fractions and learning how to do it, and it's good for that logic and the problem solving and the critical thinking. So we're just going to touch on it and make sure that we introduce it so that way you're familiar with it, even though you might not be professional at it.